All right, so this is we have some live commentary here, and so this what I'm printing here is a newer version of basically a clock spring. I'm sort of experimenting with setting producing motion in a print in place 3D print, or even an assembled 3D print, but basically a print in place clock spring mechanism to store energy and release energy to create motion like a wind-up toy, right? And so I've done a few variations of it. I have a variation here that I'll talk about a little bit. I noticed one thing: this bed, the print bed, is lifting off of the magnet, and not a huge surprise to me. But so I ended up damaging the print bed, and so while I was waiting for a new print bed from Creality, I had an old magnetic print bed from my CR10, and so I just cut it to size and I stick it on there. But I realized that the magnet is not very strong, and the piece is also not very stiff, and so it lifts. So normally when the print might lift off the print bed, it's actually lifting the print bed off of the base plate. But anyway, it'll probably be fine. This one ended up a little curved. I got the new print bed, just didn't think to put it on before I hit go on this thing. And so anyway, so what it is oh, it's kind of cool. I can see the yellow. This is obviously multicolored filament, and just sort of trying to get rid of it. I bought some thinking it might be cool, and not so much my speed, but just trying to go through this stuff. Got to use the filament, right? And so ultimately, this is how it works. So basically, the idea is that I can wind it up by this. And this one, excuse me, this one has been basically destroyed, but it works. It still works. So as you can see here, and there are some slight design flaws in this version, but like I say, printing right now, the newer version, I'm gonna, instead of letting this piece go, the hub go, I'm going to let the disc spin, because it's a better visual. See if I can. All right, ready? So that's pretty good, actually. It's got more to say there. And it's funny because it didn't work that well until I broke it in half. So basically, I pried this little flange off, which allowed it to come apart, because that normally retains it. And this is typically one piece, but I just forced it apart and it broke. You can see these little triangular. I use these as basically a standoff, so I can print with space between the floor in these coils, and it worked pretty well. The new version, I did it slightly differently, and interesting. I just had an interesting thought. Anyway, I won't go into that. But this is basically it. I don't even need that part. You can see how this works. The new version has a thicker sort of ribbon. The coil is thicker and taller. And it's only one. This one had two balanced ones. And that was just, it turned out that was just working against me. But so this is basically how it works. I can also go the other way. Oops. I'm out of the track there. Go back to the beginning here. Let's wind it back up. Okay, get it back in the housing. So because the bottom face isn't on here, it's easy for it to pop out. So if I'm basically unwinding it to the extent, reverse winding it here. And so as you can see here, that's basically, there's a lot of rotation there. Actually, while we're here, you can see this overhang. This is such a shallow overhang, and I use this technique of polygons, steps of polygons on the outer shape, and then I shelled it, so that ends up with polygons stacked up. And you can say, well, what's the big deal about that? Well, the big deal is I can print nearly flat, overhangs. There was no support under this. You could argue that this ribbon was supporting it, but it wasn't because there was, I don't know, there was quite a few layers between the two, and if that was supporting it, it would have just failed, first of all. And second of all, there's really not a lot of stringing hanging down. You can see it a little bit here. There is a little bit of stringing hanging down here, but very minimal. And most of the way, it's very much not. And especially as I get further in, it gets cleaner and cleaner for whatever reason, probably because the diameter got smaller. So you basically you take this polygon, and this is a hex 6-sided polygon here. So I had the cylinder, and I put the big polygon here, and I extruded that like maybe 2 layers worth of thickness, or a layer. Looks like very thin. And so then I extrude that up, and then I draw another polygon a little smaller and twisted, and then another polygon a little smaller and twisted, and another polygon a little smaller and twisted, until I get to the middle. And so, as you can see, it's almost flat, but it is tapered very slightly. And that allows these crazy, these crazy shallow overhang. So I'm going to let this spin one more time. Hand was kind of in the way there. But as you can see, it does what it's intended. And I have a hex, so I could theoretically I could crank this up with a power tool in a hurry. It's actually designed full size of the print bed. This one is actually printed 70%. That one's actually printed 66% because I made it a little thicker, so I wanted to still be able to get my fingers around it. So I scaled it down basically. I made the ribbon in there thicker, and to get more tension on it. I made some more clearances. There are a couple places where I was a little tight on the clearances, and I think were working against me. And especially where this flange, where I say I popped this flange off, where it comes through, I had that very tight. And also where the ribbon was here, up against the floor, it was also very tight. So I relieved that a little bit right around here in the ribbon, made the ribbon thicker, made a little more gap between, made the walls a little thicker so I could make this flange so it sort of steps, and it's like a self-capturing sort of bearing. Hopefully I don't have to break the new one apart, although with the distortion on the bed there, that may affect the performance. But I do have more vertical clearance inside from the top of the coils to the underside of the ceiling, and so hopefully, and I also, like I say, I had a double sort of redundant trying to just hold it centered, but then I realized I have these bearings holding it centered, and it works much better now that I broke one of the it was like a dual helix, dual spiral. And so I just broke out one of the spirals, and once I did that, once I removed one of the spirals, it worked literally 10 times better. So that was just working against me. Let's see if I get a good spin, get my hand out of the way. I mean, I could apply that to some toy, right? Like a downloadable toy. But anyway, pretty cool stuff. Anything else about the print? I'm not going to sit here and watch the whole print and talk to you about it. Just wanted to make a quick video because this has 3 hours and 3 minutes remaining, and I will not be standing out here for the whole thing. What else with it? Yeah, so like I say, I can make it much larger, and I could potentially make it smaller for any given application. I'm thinking about how maybe make some sort of a centrifugal governor on it, meaning so if it starts to spin in order to slow it down. So if it starts to spin too fast, then centrifugal force would have sort of pawls spread out from the centrifugal force and rub against some outside walls, sort of acting as a brake, a self-regulating governor, as they call it. So I may do something like that. I may try to make it a longer, just more turns. But geez, I can turn this, I don't know, like 7 or 8 times. Let's see, I'll count this time. Let's get it to where it wants to be. All right, so that's about neutral. Let's see how many turns. I'm going to do half turns and then I'll divide by 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10. So 5 going that way. I think I get more the other way. Let's see. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, so 8. If I wind it that way, I got a lot more. Interesting. So that's 8. I was thinking about putting a radius in this corner. That might eventually fatigue, but not as long as I don't tighten up too much, it should be fine. So that's 8 turns. Let's let it rip. I don't know, I think that's pretty cool. So next one should be even better, the one that's printing right now. And any other plans for this? I don't know. Let me show you a couple techniques. So you might be able to see here. You can't really see it there. I don't know if you can see these sort of radial lines in the hub here. So one of the first ones that I made, this hub sheared right off in the middle and made the whole thing useless. And so I employed an old trick to use, which is if you want more material in something without turning up all the infill in the whole thing, in the whole part, all you need to do is put razor thin voids through the part. So basically I'll put a 1/1000th of an inch slit through this what's sort of modeled as solid, and then so when it gets sliced, it does a perimeter around that little sliver of a slot, and I pattern that slot all around here. So there's like 16 of them or whatever, and so now the interior of this is not solid, but it's much more robust than if I had just left it completely solid, and then the infill and the slicer settings would hollow it out and add some infill. Well, I just forced it to a whole lot more of my own infill in through that shaft. So this shaft is like super strong now. Like I was crushing them before with pliers. Do I have my pliers right here? I do. I was like an earlier one I crushed so easily with maybe it wasn't these pliers. Maybe it was. These are actually really cool pliers. I just bought these recently. Channel locks. But so like I crushed the other one super easy, and I'm actually squeezing this thing really, really hard. Rah! Holy cow, I couldn't crush that thing if I wanted to now. That's because it's basically solid, because I put these voids. So voids add strength on 3D printing. Go figure. True story. As long as you're smart about it. So the void is basically 1/1000th of an inch thick, which is like, I don't know, a 1/10 of or a 1/6 or something of a piece of paper. Super thin voids. And so they're not really voids because the plastic melts to itself at the voids. But wow, geez, I wasn't expecting it to be that much stronger. I'm going to go to the end of the wrench. Man. You can see it flexing a little bit, but geez, that's strong now. That's what happens when you make it solid. So that's a little tip if you want anything to be solid that you're printing. What else? I like the way this pattern came out. I wasn't going for the pattern. I was just going for the very shallow overhang. But it looks really cool. So like I said, I made this solid, the shell basically solid, and then added these features, and then did a shell command and made it whatever, I don't know, 80 thousandths thick, or actually I think I upped it to like 110 maybe, 110 thousandths, just because somebody with a subwoofer just drove by. Some people get annoyed by that. When I was younger, man, I was that guy. When I was back in 1990, when I was at the beginning of my adolescent years. Now I'm 50, so I'm still in my adolescent years at 50. But so Let's see what else we have going on here before I wrap it up. I think that's about it for now. And we'll see how this, I'll do another one when this one completes. Actually, it's probably going to complete when I'm about out the door tonight, so maybe I'll do something with it tomorrow. But anyway, if you found this interesting, stay tuned for more of my stuff. For that, subscribe. Like the video, help other people find it if you think it was worth watching. And, share, thumbs up, like it, comment, ridicule me. That's cool. Whatever. No press is bad press. Isn't that what they say? I don't know. Anyway, all right, let's give it one more for the road. And then I'm out. One more spin. Cool. All right. Thanks for watching.